All right, so this is module 6, lesson 1. We started this yesterday in class. We are going to finish this lesson today. So a couple of reminders of things that you talked about yesterday, which were all the different types of angle relationships that we have. We have angles on a line. Remember, that's when they add up to 180. We have angles on a point, which means they form a complete circle. They add up to 360. We have vertical angles. Those are across from each other. And then we have adjacent angles, which are just next to each other. They don't really give us any other information about that. So this first example, it says, what is the angle relationship shown here? So now there's two different letters here. We have an X and a Y. We can never do those two angles together because that won't give us any information. We can't have two unknowns. So we're going to have to break that up into two different relationships. So let's start with the X. Now, we have X here. We know that this is 144 right next to it. Now, if you're looking at this, I can use my sheet of paper again. Those form a straight line. So we call those angles on a line. So angle X and 144 are angles on a line, which means they add up to 180. All right, so let's go down and just do the equation for X. So we know that X plus 144 is going to be equal to 180. Subtract 144 from both sides. To solve this equation, we get X is equal to, when you subtract that, you get 36 degrees. All right, so now we have to do angle Y. Now I'm going to go up and just mark that this is 36 degrees, so it's in my diagram. And we can do angle Y in two different ways. Now that we have angle X, we can see that angle X is next to Y and it forms a straight line. See my green line? Or we can say, look at, I can draw an X with these two lines. When you draw an X with those two lines, the angles that are across from each other are called vertical angles. So vertical angles are always equal to each other. So let's do that one. We have angle Y and 144 are vertical angles. Which means, what does that tell us? Vertical angles are always equal to each other. So that means Y is going to be equal to 144. Now notice we don't have to solve anything because we have Y is 144 right away. We don't have to solve any equation. Now let's go back and make sure we have angle LEB. Trace it, LEB, which is X. We know X is 36 degrees. And angle KEB is Y, which is 144 degrees. So there's the measure of our two angles. All right, so let's take a look at the next example. All right, it says describe the angle relationships. Now, if you were looking at angles on a line, okay, I could take my green sheet of paper, I could do this. The problem with that is we don't know this angle. It looks like 90 degrees, but it doesn't tell us that, so we can't assume. So we can't do angles on a line there. We can't do angles on a line here because we don't know this angle. We can't do angles on a point because that means we'd have to know all of the angles. So the only other option we have is vertical angles. Now, I'm going to use my highlighter again, and I'm going to trace this one and this one. There's my X, which means the angles that are across from each other are equal. So I have drawn the two little circles that show us the equal angles. Now, this angle, these two angles that are next to each other form, when you add them together, form the whole big angle. That's the piece of information we need to know. So we have 3x plus 16. When you add those together, it makes the whole thing. And the measure of the angle down here, which is 85. Those are vertical angles, which means they are equal. Just remember, vertical angles are always equal. So let's write the equation. These two angles added together, 3x plus 16, is going to be equal to the bottom angle, 85. Now this is just a two-step equation, so we're going to subtract 16 from both sides. So we're left with 3x equals, take your calculator, we're going to do 85 minus 16, which is 69. Divide both by 3, so x is equal to 23. Now all this is asking us to do is solve for x, and that's what we've done. All right, example 3. Okay, describe the relationship here. Now this doesn't have any measurements, but we know that the box means that it's 90 degrees. So let's fill that in. Now there's no straight lines for any of these, so we can't do angles on a point or on a line. Nothing is across from one another. It doesn't form an X, so not angles on vertical angles. But we do have all three angles, and they all form a circle. So I'm going to write all three angles are angles on a point, which means they add up to, angles on a point form a circle, and circles make 360 degrees. Make sure you write that they add up to 360 and that they are not 360, because that would be a whole circle for one angle. All right, so let's write this. We have three angles. We have x, 135, and 90. They all add up to 360. So we're going to combine these two first. So x plus those two add up to 225. Subtract 225 from both sides. So x is equal to 135 degrees. Now it says find the measure of EKF. So take your pencil, EKF is x. And we already know that x is 135. We are not going to measure that with a protractor. All right. I'd like you to try exercise 3 on your own using all the relationships that we just learned. So pause this video, try exercise 3, and then make sure that you resume the video to make sure your answer is correct. All right, so we have all four angles here are called angles on a point. Which means they add up to 360 degrees. All right, so let's take those four angles. We have x plus 1, that's one of them. We have 59, we have 103, and we have 167. They all add up to be 360. So now we have four numbers here that we have to add together. So I'm going to do 1 plus 59 plus 103 plus 167, and that gives us 330. So subtract 330 from both sides. So x is 30 degrees. Now this question is asking us for GAH. Now that's x plus 1. So since x is 30, the whole angle would be 31 degrees. All right, example 4. So right here we have two lines that intersect, and we have the ratio is 2 to 1. Now when they give you a ratio, that means it's 2 parts for every 1 part. The problem is you don't know what you're multiplying by to get those actual angles. So I'm going to label this in the diagram. Obviously the angle that's bigger is going to be the 2 parts. Whenever we don't know what the part is, we use an x. So that would be 2 parts to 1 part. Now these two angles here, okay, the angle relationship is if we bring out our paper, it forms a straight line. So we're going to say the two angles are angles on a line, which means they add up to 180 degrees. All right, so let's write our equation. We have one angle, which is 1x. We have another angle, which is 2x. And they add up to 180. Well, 1x plus 2x is 3x. So divide both by 3, and x is 60. So the acute angle was 1x. 1x is just 60 degrees. And the obtuse angle, which is the 2x, we have to do 2 times 60, which is 120 degrees. All right, same thing with exercise 4. I'd like you to pause the video and try this one on your own, and when you're done, just check your answers. All right, so this relationship is already labeled 2x to 3x because that's the ratio. We know that it's a 90-degree angle, so those two angles that are next to each other form a 90-degree angle. So the two angles add up to 90 degrees. So let's write the equation. One angle is 2x, the other angle is 3x, and they add up to be 90 degrees. 2x plus 3x is 5x. Divide both sides by 5. So x is equal to 18. Now, question says find GFH. So GFH is 2x. 2 times 18 gives us 36 degrees. Angle EFH is 3x. So 3 times 18, because 18 is your x value, is 54 degrees. Now, if you just do a quick mental check, 36 plus 54 should add up to 90 degrees, which is what you were telling me before. All right, so your homework for this lesson is just going to be to finish up the problem sets. That's just numbers 4 and number 5. Have fun and good luck.